This will be recorded. I just kick off the recording now. My name is Jason Silver. I work with Semperis. I'm a delivery engineer here. So what that means is I'm sort of a technical contact for you folks as well, if you do choose to further the discussion along the way as well. I'm going to kick off a little poll here, get an idea of what kind of things you've been doing along these lines. And let me see, launch that right there. You should see it up on your screen right now. I'll just leave that there for a couple of minutes while I allow Sean to actually introduce himself as well. Sean.
Hi, Jason. Thanks for having me. Yeah, so this is obviously I'm Sean Dubey. I've been working, I like to say I've been working with Microsoft Identity as long as Microsoft has been working with Microsoft Identity. So all the way back to NT3.1 beta, and then working on, deploying NT for Texas Instruments around the world, and then 10 years with Intel. I was one of the architects of Intel's Active Directory Forest, and then on the Directory Services team for, as I said, for about 10 years. And I also, as you can see from this also, I do a lot around speaking and writing about Active Directory, Azure Active Directory, Microsoft Cloud Services, all that sort of stuff. Because I was former, and where I knew Jason is formerly a technical director for Windows IT Pro magazine. So this is my 15th year as an MVP in essentially identity. Microsoft used to call it Directory Services, and now they call it Enterprise Mobility. So.
All right, thank you so much. We're going to go ahead and close this poll out. Thank you for those who took a moment to quickly do an answer there. And Sean, let me quickly make you the presenter, and we can see the good stuff.
Okay.
There you are, sir.
Okay, so let me just choose the right screen here. Looks like monitor 1. And let me know if you can see that.
Yeah, I can. Yeah, you're on the same title screen that I had up. Thank you.
All right, good stuff. So yes, so I was struggled with what to call this, but so I came up with defending your organization against its own people, and it's not your people's fault, really. It's Password's fault. I've already talked about this. There's a picture of me with looking scrubby, so we've got all that. I'm at Shorin Sean on Twitter. The main thing that I do on Twitter is I watch the Azure Active Directory blog like a hawk, and when new announcements or new enhancements come out every few weeks at this breakneck pace that Microsoft is working on cloud stuff, I will retweet it. I will retweet it and try to add some kind of a minor value add commentary. So today, what am I going to talk about? So the first is a popular topic among system administrators and identity people is passwords must die. Always a good way to start things out. Then I'll talk a little bit more, dive into this relatively new attack called a password spray attack. Great name, unpleasant attack. And from there, get into Azure AD password protection and talk about the different aspects of it. What is the architecture of it? What are the various components and what they do? And when it's all screwed together, how does it operate? And a little bit on the tail end about Smart Lockout, just because it's closely associated with password protection in the Azure portal itself. So I think by now, most of us pretty well recognize that passwords, where everybody keeps refocusing on better passwords, stronger passwords, more complex passwords, but the bottom line is that they're essentially no longer defensible against modern attacks. The users, they just can't devise complicated password generation methods that are adequate without using a pattern that can be discerned by some kind of a computer or even if they do have something like that, repeating it between websites. And the reason is it's what I call the wetware. The human mind can only generate and maintain a certain amount of complexity for a password, and then take that and then have to come up with new passwords. And for new sites, it's just not possible to do. Credentials attacks are all over the place. This is a hard. I love looking at Azure statistics because the numbers are just mind-bogglingly large. So in August of this year alone, Microsoft blocked over 1.3 billion credential attacks against Azure. So just an amazing number. And across the world, not just Azure, compromised credentials were responsible for phishing. 91% of successful attacks were by phishing. And of course, in phishing, the user is tricked into revealing their user ID and password. 53% of security professionals reported spear phishing, not just the general phish, but a very highly targeted phish designed to social engineer the target into revealing their credentials. 73% of passwords are duplicates, which if anybody that's not a professional security person and is really paranoid about it, use repeat credentials all the time. It's because of our human limitations. And then 50% of the compromised credentials were using the top 25 most common passwords. And if you want, you can see I've got footnotes with that at the end of the presentation. I've got links to all of the studies that report this information. So, most common passwords. We have been working with password policies since 2000, probably, maybe earlier. And so they're old. They've been around for a long time, and they are resistant to change. Imagine, someone walked in and said, "I'm sorry, you need to change your base password policies radically from how they are today." You would say, "No, go away. Who are you? Why should I do this?" It's deeply ingrained in us. And that's stuff like policy expiration, how long before a password expires, password complexity and composition requirements that we've all, included, and password length. Well, the reality is times have changed, and a number of studies, both new and older studies, shows that these policies are obsolete. Last year or a couple of years ago, NIST published its digital authentication guidelines draft and said you can't do the same thing with your policies that you've done before. Microsoft Research published a report based on analysis of more than 10 million user ID and password attacks it sees every day. And it also, of course, collects compromised credentials. And the Federal Trade Commission CTO's blog cited conclusions from Carleton University and UNC Chapel Hill to get to similar conclusions. So what are they? At a general level, they are: 1, don't expire passwords. 2, don't enforce password complexity. 3, require a minimum of 8 and allow up to 64 character passwords. And that would include spaces in Unicode, which, like emoji. Now, I know most, certainly Active Directory can handle that, and most websites that I'm aware of can handle spaces and emoji. Although, and frankly, I'm not sure how I'd enter an emoji in a password. But anyway, this is something to work towards. Banning common passwords. And probably the most controversial one, which is to don't change passwords after compromise. The point behind this seminar is not really to dive into these, and I have a few blog posts on the Semperis site that does go into this in more detail. But so we'll focus on banning the common passwords. But to reiterate what I said before, what triggers it really is the human brain, what the human brain can handle. the amount of complexity and changes it can handle. Now, something I do recommend to augment the human brain is a password manager. But that's a whole other, that's, like I said, that's a whole other topic. I'm a big believer in LastPass. I use LastPass for all sorts of stuff. And I have a bunch of really hairy, gnarly, long character passwords that I use as a result of using LastPass. But to common passwords, all of the studies agree on this. Common passwords are the first one to be compromised because obviously they're the first ones to be guessed. A 2016 study of 10 million passwords found that the top 25 common passwords, and the examples on the right are some of them, which are just amazes me, comprise 50% of the 10 million successful password breaches. 17% of that 50 use 1, 2, 3, 4, 5, 6. So that's bad. And most cloud services don't check this. Azure Active Directory does. I can't speak to, a lot of the cloud website SaaS applications, they don't do this kind of checking. Active Directory itself doesn't control this out of the box. So continuing the common passwords theme is password spray. And I describe as a password spray as a brute force attack, only upside down. So in a brute force attack, you take one user and you hammer it with a bunch of passwords, from a rainbow table or a dictionary attack, and you hit that user again and again and again. And monitoring and security software knows to look for that because it can see the activity. A password spray turns this concept upside down, where it takes one password and then it hits many accounts against it. So it would hit, and you can see here, well, let's try Red Sox 2018 against this account. No, not, how about that account? How about that account? How about that account? It's much harder to detect because it's not hitting just a single account. It's hitting many different accounts. And if the attack is designed correctly, it can stay under traditional alert thresholds. Microsoft has seen it take up to 6 hours between attempts of using a common password against different accounts. And with a distributed attack, it can be spread across not only many days, but many different source IP addresses. This is the sort of thing that a cloud service does a better job recognizing than, say, at a single point, like a VPN access endpoint into a company. There was a US CERT notification out, it's close to a year ago now, talking about the password spray attack, brute force attacks conducted by cyber actors. You'll be able to get this link when you get the deck, but you can also do a search for that and find out more about it. This is a slide from Microsoft and from Alex Weinert of the Azure Identity Protection, the leader of Azure Identity Protection. And what it shows is a password spray attack across a number of days. So we have from 2018, from June 18th to 2018 to June 21st. And each one of those different colors is an attack of a particular password. And so you can see it spike up and begin, and then it goes back down again. And then it spikes up a little bit, and then it goes down again. Some of them are short-lived. Some of them are much longer-lived. So very, very difficult to correlate these different sources and different signals to even know that you're being attacked. Well, I think we already had this. Whoops. Let me go back. My apologies. So, Jason, did we get a response to this question? Or no, that was you had the password filter question. Did you ever get a response?
I had, no, this was the one I had. So the other question would have been what you see if they use a password filter. The first one I used is, do they monitor for this?
Okay. Well, so now if we can do this polling question, do you currently monitor for password spray attacks? You can say, yes, we do the more traditional where we monitor failed password attempts over threshold, or we report on locked out accounts, or we don't have this, but we'd like to, or we have it, but we haven't done it. And if you answer D, I want to know why too, but I'd certainly turn it on.
Absolutely. Yeah, so by the way, the poll for this one was about a 50-50 split with the attendees of they report on locked out accounts, and we have the ability to monitor this. Sorry, we don't have the ability to monitor this, but would like to.
Right. That makes
No
sense.
one answered D on that one.
Well, and that makes sense because the traditional monitoring reports locked out accounts. And obviously people would be interested in monitoring this attack.
Yeah. Perhaps for a show of hands, this would be a good time to do it as well, because you're talking about the ability to reject common passwords. Just a show of hands inside the panel. Are you folks, do you use any third-party password filters to reject common passwords now? Yeah, one or two going up. Yeah, it looks like there's a couple.
Okay. So maybe they're checking onto newer ways of doing it. Yeah. Well, obviously, if you're here, you know that your Active Directory is vulnerable to a password spray attack because of the common passwords, because it has no out-of-the-box defense. And you know also that your users have reused their AD credentials. That's just the way of the world. These are the credentials that they probably use more than anything else, logging into the corporate environment every day, and so sure they're going to reuse. If not their user ID, they're going to reuse their password. And by the way, that's my dog. It's not stock art. So yeah, the password complexity filter in Active Directory does not comprehend common passwords. There are third-party password filters available. I found an open source one called Open Password Filter, which is actually in alpha. So I'm not sure I'd install something inside LSASS that's in alpha. But there are third-party password filters from Nfront, Anixis, and a couple of others. They all use, to my knowledge, they all use static dictionaries. They have a dictionary of passwords that they can check against, and that's the one that they use unless somehow it gets updated. What I'm here to talk to you about is Azure AD Password Protection. It's actually a misleading name because it can protect Active Directory, even though it says Azure AD Password Protection. So at a high level, what's it all about? Why should we care about this new capability that's in public preview right now? So first off, it provides common password rejection at the domain controller using the domain controller's own tools. It uses a banned password list that is built from machine learning, the Microsoft Intelligent Security Graph, to form the backbone. This is a list of 1,000 passwords that is culled down and culled down and culled down from the 6.5 trillion signals a day that Microsoft Cloud gets from Azure Active Directory, the consumer version of Live, Xbox, and its other cloud properties. It determines the 1,000 most common passwords currently being used in attacks against the Microsoft Cloud system. Now you can take that list and you can augment it with a custom list as well. So if you're working, for example, you're working in the auto industry, your corporation it's an automaker or it's an auto supplier or something like that. And as a result, a common password potentially for your company are the names of an auto manufacturer or a make or a model, not a make, that is a make, or a model of a car. You can augment with a custom list that will allow you to ban those common passwords. The same thing that an attacker might guess. Another nice feature is that it doesn't require internet connectivity for the domain controllers. They don't have to have internet connectivity themselves. There's a proxy, which I'll explain to you, that does the work. It hardly even requires corporate network connectivity. The only connectivity it really requires is that the domain controllers can talk to each other, and that one domain controller can talk to a proxy server that's also on premises. So let's talk about the architecture a little bit. This is a fairly complicated looking slide, but I'll break it down into pieces here. Pull my little laser pointer. So over here we have Azure. So we've got Azure Active Directory and the password protection service here. Here is the administrator that is applying changes and administering the service. In the middle, on premises, this sort of, I'm not sure what color that is, this lighter color is on premises. So here's the proxy. The proxy, you see in this case, there are two instances of the proxy that is used so that the domain controllers don't have to have internet access. And here are a couple of domain controllers. And on the domain controllers, you can see we've got LSASS, and we've got sysvol, and we've got replication going between sysvol. And then up here at the top, we have the users. We have the user that is going and attempting to make the password change. And I'm going to drill down into each one of these in more detail. So the Azure AD component. So what's it all about? So it contains, this is a blade that I'm going to show you in Azure Active Directory. It contains the basic service settings, it has the custom list settings, and it has the smart lockout settings. From an architectural point of view, we have an abstract that shows here's the machine learning that's going on in Azure, and it's taking all of its data and it's reducing it down and creating a global banned password list. In addition, this is where I said the user can create, or I'm sorry, the administrator can create a custom banned password list. And these two are put together into a consolidated banned password list in the Azure AD protection service. By default, it is turned on in audit mode. This is the password protection service, and I'll show you that in a second. It's important to note that even though you can influence the custom banned password list, you cannot influence and you cannot see the global list. The intelligence to build a global list comes from about 4 billion exposed credentials. Azure AD right now already supports banned passwords. This is an example of what happens when you try to update your password, and you can test this on any of your cloud accounts. Is if you put in a password that's a simple password, you know, like pass@word0rd1, something like that, it'll tell you very clearly, we've seen that password too many times before. Choose something harder to guess. So, oh, and let me go back. So here we're on this. Let me show you what this looks like. So this is my lab. This is hybrididentity.net. And let's go into Azure Active Directory. And as I scroll down from Manage down to Security, there is a new item under Security called Authentication Methods. And right now that has just one thing in it, but it will be built out in the future with more features. This is password protection. And here we have custom smart lockout, which I'll talk about a little bit later. And here is the banned password, the custom banned password capability. By default, it's turned to no. I have it turned on, and I have added some examples if you worked in the auto industry of common passwords someone might want to try to use in the business as an easy password to remember. By default, the password protection is turned on, but it's set to audit. I have it set to enforced. By default, in your tenant, it's set to audit. So what that means is that it's nicely thought out to be non-intrusive. You can go through and you can install password protection, and what will happen is it will immediately begin reporting in the event log of users that are entering common passwords or to reset their passwords, but it doesn't interfere with them until you change it to enforced.
Sean, real quick, not to interrupt you, but a question had come in a little bit earlier. Like, how long would it take to implement this? Let's see, what kind of time should we plan on to install a password filter? So, given this, it looked like it was almost immediate. But do you have any experience in third-party ones outside of the Azure AD one?
I do not have experience with third-party password filters. For installing this, it takes, other than getting through some little hiccups in the installation process that you kind of have to watch for, it takes a half hour, something like that. It does require a reboot of the domain controller because you are changing the password filter.
Yeah,
And I'll actually show you a little bit what that looks like in a second here.
fantastic. Thank you.
So the proxy service. So the point behind the proxy service is simply to allow domain controllers to get the banned password list from Azure without requiring internet connectivity. It's a very, very simple service. It's kind of a relay service. If when a domain controller asks a proxy to get the banned password list, it forwards it to the password protection service in Azure. When the banned password list comes back to it, it forwards it back to the requesting domain controller. Very simple agent. You can install it on any domain join server. Maybe this would be a good thing to put on your AD Connect server, for example. It supports a total of 2 password instances right now to give it high availability in public preview. It is planned to allow it to have more than 2 once it's generally available. If you think about it, this is an important service, but it is not a time critical service. The banned password list doesn't change that dramatically over any small period of time, hours, days. And if the password proxy, if the proxy is not available for whatever reason, the domain controllers already have, once it's up and running, the domain controllers already have a banned password list that will remain highly accurate for a long period of time. It's available in the download center. There's a link there, but all you have to do is look for Azure Active Directory Password Protection download, and that'll get you to it. As part of the installation service, you have to do a proxy. You have to register the proxy service, and you have to register the target Active Directory. So, and I'll show you a video of this. I'll show you a video rather than a live demo because it can take a long time. It's perfectly normal, but sometimes it can take a long time to register in Azure. So I cut out the wait in this video. One thing to note, and I'll show you one in the video for it. So this is, here you can see the password proxy executable. So the password proxy installation is very straightforward. Just run it, does the installation, and it's done. Now, what I'm going to do here is I'm going to open a PowerShell prompt as administrator, and I want to confirm, because I've had some issues with this before, that the installation of the proxy service has also added something to an environment variable for PowerShell. The environment variable is called PS module path, and it shows that yes, it did add the password proxy module into the path. So what I'm going to do is load the PowerScript module. I'm going to do an import module, but I wanted to make sure that it was there in the first. Module imported, that was no problem. The next thing, let's check and make sure that the service is up and running. Get service. And it's good. So now what we're going to do is we're going to register this service with the customer's Azure Active Directory tenant. And this is the step that may take a few minutes. At this point, there is a known limitation, as Microsoft would like to call it, and that is the goal. You have to register you have to use a global administrator of your tenant to do it. But this method does not currently accept multi-factor authentication. So you have to turn off MFA for your global admin, and then run this procedure and then turn it back on again. So I turned it off on mine and then turned it back on again. You know, people are unhappy about it, but hey, it's public preview and it's 3 minutes to turn it off to get this done. So that's the registering it with Azure AD. And now with the second command, we're going to register the local Active Directory with the service as well. Register Azure AD password protection forest. And this is asking for my domain administrator creds. This one is much faster and it's complete. So that's it. This is just a little query that looks at the configuration, which is very unimpressive. And it just gives you the service name and it gives you the display name and the fact that it's, on a standard port. So that's what the installation of the proxy looks like. It can take a few minutes longer if there are just a couple tricky aspects to it, but all in all, it's pretty straightforward. Now, the domain controller agent and the password filter, this is where the heavy lifting gets done. The DC agent is really the heart of the evaluation process. So it performs the common password evaluation in runtime, and in the background and admin time, it also manages the banned password policy. It policy checks to make sure that it has a reasonably new version of the policy. If it doesn't, it requests the banned password list from the proxy. And then when it gets it from the proxy, it takes the banned password list and actually builds a password policy that it then puts on sysvol. So this is the DC agent service that's installed on the domain controller. And then within LSASS is a password filter. Password filter has been around since Active Directory's been around. It's a core part of Active Directory's LSASS service. All this password filter does is forward password requests to the agent. They specifically made it as simple as possible. It does still honor password complexity if you have the password complexity policy set. So that is part of it as well. To install it on a domain controller, the DC has to be Windows Server 2012 or newer. And as I said before, because this is installing a password filter, a reboot is required. So as you're evaluating these things, bear that in mind. If there's a way to do it with command line executable if you have a lot of DCs you want to install it on, but be very careful because it will automatically reboot the DC, and you never want to reboot a DC unless you intend to. So in a little more detail about the password policy creation and distribution, it works like this. So if you look at this flow chart, so the domain controller agent looks to see if there's a password policy on sysvol. If there is a password policy on it, it checks to see if it's current. Let's just say that it's current, that it's good, and then it performs a password evaluation for the users and everything's good. And mind you, this is a very, very lightweight service. The communication is very, very little. You don't have to worry about domain controller loading. You don't have to worry about network loading. The guy that wrote this on-premises portion is a senior dev lead for Active Directory. So he knows it. He's forgotten more about Active Directory than you have ever learned. And so he has designed it to be super, super lightweight and to not interfere with normal domain controller processing. So only one domain controller per site will even go check for a current policy. And then it will pass it around to other domain controllers. So let's say there's a password policy on sysvol, but it's not current. So it's not current, it sends a request to the proxy, which is registered in Active Directory as a service configuration point to find where the proxies are. It sends a request for the banned password list from the proxy. Proxy goes off to get it. It gets it back from the proxy. It creates the password policy in the background, and then it writes the password policy to sysvol. At this point, the password policy is on sysvol, and then it is replicated to all the other domain controllers in the domain via sysvol. None of the other DCs has to do anything. So by and large, Microsoft has said they expect, one DC, because of replication time and all that, one DC to be making this request, probably for an entire domain. And this process repeats for other, in other domains as well, because the scope of sysvol, as you know, is just at the domain level. So very, very flexible, very tolerant of all kinds of network topologies. With it actually in place, this is what the authentication flow has. Pretty straightforward. The user contacts the domain controller to change their password or to reset their password, and it's received by the custom pass filter, and then it is passed on through to the DC agent. The DC agent does the evaluation, and I'm going to drill into a little more detail about what that evaluation looks like. And then you get a success or a failure returned to the user. Now, there's a facet of this to be aware of, and part of the beauty of this architecture is that the password evaluation, the expanded functionality, comes out of the normal, password process on Active Directory. The drawback is this expanded functionality, this expanded control, still returns the same message to the user. So if the user gets their password rejected because it's a common password, they will just get the message that says, I'm sorry, your password does not meet complexity requirements. So one thing you have to factor into any kind of a deployment of this is lots of end user communication saying, look, this rejection of your account now may also encompass the fact that you're using a very common password, or you're using a very common phrase inside of your password. This opens a conversation with your security people by, if you go back and you look at the NIST guidelines and the Microsoft recommendations, but certainly NIST, is to ease some of your other restrictions as long as you ban common passwords. So it's my belief that by enabling banning common passwords, you will be able to ease up on some of the other requirements, so that it's not quite so onerous for your users. So in terms of the actual process of the evaluation of whether a password is accepted or rejected, I have this from Microsoft as of a few months ago. They reserve the right to change it as attackers change their methodologies, and things evolve. But this is the way it looks today. So there's sort of a coarse-grained evaluation and a fine-grained evaluation. So the coarse-grained evaluation is, does the password match anything in the consolidated, meaning the global or your custom list, banned password list? Is it a straight match? Pretty obvious. The second one is, does the password match after doing a character substitution? In other words, substituting a $ for an S, or an L for a 1, or a bang for an exclamation point. Let's face it, even though we all still use that sort of thing and it makes us feel better, they figured out by now that that's not going to help you any. So character substitution. The fine-grained evaluation is done on a point scoring system. So the first pass on it is if there are found substrings in the password. So for example, in this one we have a substring of spring and a substring of 2018 and a substring of ASDF. Those substrings are worth 1 point each, so that's 3 points. And the remaining characters that don't fall into the passphrase or don't fall as a common password are 1 point each. So you've got J236, that's 4 points. So 3 plus 4 is equals 7 points, which is more than 5, and then it passes. The idea here is to strike a balance between minimizing the use of common passwords and beating the poor user over the head with, a combination that they can never hope to achieve. So let's see what this looks like for the real thing. So what I have here is one of my virtual machines, and you'll see it's a domain controller. It's got a little DC on the end of it here. And I have a password prompt here. And the simplest way to test this sort of thing is with the net user command. So if I want to take net user, and the user I want to work with is user1, and let's do just a simple one, blah. Well, that doesn't meet complexity requirements. That doesn't even meet the complexity requirements that have all been there if you have the password filter turned on. If I change it to, let's see, blah Betty blah, that's probably a good complex password, and it accepted it. Okay, so let's take, and you saw, for example, in the custom, and that's all normal behavior. Let's take a word that's in the custom password list, and let's try that. Or let's take the infamous pass, or let's say pass at word 1 that we see in so many demos. Oop, didn't work. It passes the filters, the base complexity requirement. It's got an upper, a lower, and a numeric and a special character, but it didn't allow it. That's off the global password list. If I go and look at the custom list, let's put in this one, CHRYS1ER bang. That's got an upper, a lower, a numeric, and a special case, and it's the right number of characters, but it fits the custom profile. Rejected it. Now, when we go look in the event log, so where I am on this, let me thin this out just a little bit so you can see. This is under Application and Services log, Microsoft, DC Agent, Azure Password Protection, DC Agent, and Admin. And now let me refresh this. And we see, and from the DC Agent, the reset password for the specified user was rejected because it did not comply with the current Azure password policy. Please see the correlated event log message for more details, which is this, and frankly doesn't spend a whole lot. It just says it was rejected because it did point out that it was the per tenant banned password list that rejected it. So I bet if we go and look at this previous one, it will say the global, yes, present in the Microsoft global banned password list of the current Azure password policy. So that shows how it works from the user's point of view. Kind of real briefly, whoops, where'd that go? Real briefly about Smart Lockout, and let me get rid of the pointer here. I don't need it anymore. Smart Lockout is similar to the lockout that you have on premises in Active Directory, except it uses machine learning to intelligently lock on credentials attacks against Azure AD credentials attacks, not on premises, but people trying to log in with Azure AD. So, you can see the lockout threshold is 10 attempts, and after 10 attempts, it will lock it for 60 seconds. Now, if after the next sign-in, after the unlock fails, the account will lock again immediately after 1. And if the account locks keep happening, the lockout duration will increase with every failed attempt. It's turned on by default. It's included in all Azure AD versions. You don't have to do anything about it. It's just there for you. If you should feel some need to adjust it, and frankly, I wouldn't. They made a very clear reason to do that. I would leave it. Here's a question. So what kind of Azure AD licenses does your organization have? Because there is licensing associated with this, depending on what you're looking for. So I'm assuming, Jason, that you're putting up the poll. I can't see it.
I just did. Just took a few clicks. It's up right now.
Okay.
I'll leave this up there for a minute or two.
Okay.
And actually, while it's up, if I could ask, is Azure AD password protection available now?
It is available in public preview right now, and it is expected to be generally available in the beginning of next year, Q1 2019. Wow, I have not had to say 2019 before. Yes, Q1 of 2019.
Yeah, I have kids in school still. I say 2019 a lot. Actually, we might do another. What version of AD do you need to run Azure AD password protection?
In terms of domain functional levels and forest functional levels, I might have to look it up, but I would say probably 2008 or above. A safe bet would be 2012 or above, but really, if you think about what it's doing, it's using a password, it's installing a password filter that's been around since AD was invented, and it's using sysfile replication. One thing I would add is that for it to work for sysfile replication, you have to have moved sysfile replication away from FRS to DFSR, which has been around for a long time, but there could be some old AD installations that are still using FRS.
Yeah, good point. And this one is actually from me, because prior to us starting to talk and plan up for this thing, I misunderstood. I always thought that when I was reading about this, that it was only for Azure AD, but for what you were saying today, and for the benefit of everyone else, this works in both Azure AD as well as on-prem.
Right, that's right. Do we have, what have we got back from the poll?
It's about an 80-20 split, actually. Most of the folks on today are using Azure AD free, but some are using E3.
Right, okay. So let me go forward and talk about the rest of this very briefly. And it's important to point out that this is only one part of the solution. Passwords are still weak. It only protects against this kind of attack. Everything else from a password weakness still applies. So this quick code up here leads you to a Microsoft site that talks to you about how to have a broader sense of security. Look at this number. Multi-factor authentication reduces compromises by 99.9%. That is the number one thing you can do to prevent compromise. If you have automated risk policies, that reduces compromise by 96%. And now in this, we're talking about Azure Active Directory Identity Protection, which is a premium service for Azure AD Premium P2 or EMS E5. However, for your EMS E3, the listeners in the audience, you can use what is called the risky sign-in report that is generated after the fact. This is automated risk policies are real time at login through identity protection, but you can still find out who your risky users are by going into Azure AD and looking at the risky sign-in report. If you block legacy authentication, very important, reduces compromises by 66%, because that ensures that everybody goes through conditional access policies. And this is a fairly far out there. This is Azure ATP. This takes EMS E5 to do this, but it's this is the Azure ATP, and its little brother, Advanced Threat Analytics, are services that are on your domain and monitor your domain controllers and look at common attacks like pass the hash, pass the ticket, and also learn through user behavior analysis when Jim Bob, who has always gone home at 5 o'clock, suddenly at 11 o'clock in the evening is doing a mass download over the VPN from a server. So that's what both Azure ATP and ATA protect against. And then cloud app security for your cloud applications to have monitoring and alerting of your main cloud applications. So,
all right. Sorry, real quick,
yep,
just not to interrupt you again.
Yep,
If you
done.
jump back real quick,
Yep.
if anyone was trying to pull their phones out and grab that QR code, just remember, you will get a copy of this deck along when we send the link to the recording of the webinar. And if you want to get it right now, if you look in the handout section of the GoToWebinar panel, you can actually just grab it from there as well.
Right.
Thank you.
Yep. And it's just security steps, aka.ms security steps. So to quickly summarize, so we still have some time for questions. Password spray attacks are dramatically on the rise. You know your AD is vulnerable to them. This uses machine learning plus built-in AD password processing to protect against common passwords. You should evaluate it today. Now, because it's public preview, technically, you're not supposed to be deploying it to production. I would, I think some of its benefits are so powerful and it's pretty stable that I've experienced. I'd give it a very strong, careful look. But it doesn't reduce the need for other protections. And there's statistics you'll see, you've got that's to download and the other stuff about it. And what have we got for questions, Jason?
Well, actually, we went through them along the way. There was one that had come in early on, though. Could password filters be compromised and share passwords out? I guess maybe that custom list was the more offending one that people would be worried about.
Yeah, I mean, the tools like Loftcrack and Mimikatz, if an attacker wanted to share, they wanted to take passwords out of Active Directory, what they would do, if you could get to the point where you could get to a password filter, the attacker would already be on the domain controller and then run a tool like Loftcrack or Mimikatz to attack the Active Directory database and pull the passwords out that way.
Yeah, good point. Good point. I'm going to take presenter from you.
Sure.
For a moment or two. All right. So real quick, just a few minutes left. I won't take too much more of the time here. I wanted to talk a little bit about Semperis. Like I said in the beginning, we are an identity protection company. We do focus heavily around on-prem AD. More related to what we talked about today, it's a matter of monitoring the changes or the activities around Active Directory itself, being able to report on those. There are some reports that exist for tracking lockouts as well, tracking accounts, without an expired password. I know, Sean, in the beginning you were talking about some of those recommendations, some of those guidance around not expiring passwords. I'm actually on board with that. But as you look further into that, it does kind of go into sensitive accounts or accounts that protect critical data. It's not all cut and dry on don't expire everybody. So you may want to actually see some of those privileged accounts, what kind of activity that they're running to get an idea of, are we compromised? On the other side of the house, if it all goes down, either logically or these days more likely as a result of a breach, we do have an automated forest recovery as well. So with a couple of clicks, you can get the entire forest back from absolutely nothing. I'd love a chance to kind of show you a little more detail about what these things do around identity and around AD protection as well. So yeah. I think
I was going to say, Jason, it's a good point. Especially when you look at service accounts with passwords that don't expire over a long period of time, and you have, say, a service account that runs a bunch of SQL clusters, multiple SQL clusters across the company, and somebody changes the password. Or there's a circumstance where the password gets reset and it's lost, and they don't know what the old password is because it's been around forever and it's been forgotten.
Yeah.
That's when, you know, Active Directory recovering the state of that particular password would be a lifesaver.
Yeah, I've never been there. It's funny, the more you went through it, because in my previous life prior to this, I was where I met you, Sean. Actually, I was a product manager with Beyond Trust, and dealing with the PowerBroker Windows, all the least privileged stuff. So passwords and permissions and privileges and protecting all of this is very near and dear to my heart. So with that, I really thank you, Sean, for jumping on and showing us stuff, myself included, that you know we may not have been too up to date on what these things were. We're always having to learn about something new. So very informative, very well done, and thank you for that.
Well, it's my pleasure. I think that this is an important feature that people need to be aware of. One little last tidbit to mention, the reason I asked the licensing question. So there is, because it is an Azure AD service, there is some basic licensing required. It depends upon what level of capability you want to have for it. Many of the full configuration with the banned password list and all that requires Active Directory Premium P1 for every user that is synced to Azure Active Directory. So if you don't have a big presence in Azure Active Directory right now, if you have a subset of users that are synchronized up to Azure Active Directory, those users have to be licensed for Premium P1, or obviously EMS E3, to use that. So that's something to keep in mind. And all of this information is the details of this are available in the Microsoft Docs.
Wonderful. And continuing the conversation, Sean, I will see you next week. Sean is one of our speakers next week at the Hybrid Identity Protection Conference in New York. I know it's coming up next week, but if you can find or will be finding yourself in the area, please go ahead and join us for the HIP conference that we're sponsoring Monday and Tuesday of next week. There's a link on the bottom there. Again, the handouts are available as well and will be sent again. But this is a great opportunity to dig in deeper on all things identity, Azure or on-prem, and that's about 20 somewhat speakers that will be speaking over the course of those 2 days. Really encourage you to take a look at that.
Yeah, it's a star-studded speaker list, including the Director of Identity Standards for Microsoft, a bunch of MVPs that have been doing this for a long time, and some of them will get down on the metal and what's going on inside Active Directory.
Yeah. All right, folks. I'll give you a day back. Thank you very much for joining us today. Again, Sean, thank you. The recording will be sent out to all who have registered and attended, along with the deck for the slides as well. Appreciate it. Thank you.
Thanks, everybody.